brings us down to the feasible region, right? Now, so far, so what, right? So what are we trying to do with this? Which one of these combinations would be the best one to use? Well, that depends on a lot of things, right? Maybe it depends on your labor costs in the baking and mixing departments. Maybe it depends on the amount of materials you need to make cake or sugar cones. Maybe it depends upon the profit that you bring in based on cake and sugar cones. And in fact, we're going to look at a scenario where the revenue is what we know. Suppose a batch of sugar cones sells for $535 and a batch of cake cones for $419. So we know how much money is coming in. What combination of cone manufacturing would make the revenue for this company maximized? How would it maximize it? So if we want to maximize the revenue, we need to come up with some kind of formula for the revenue, right? We could take each of these points back here and we could plug them in and say, 2 times 419 plus 4 times 535, right? We could do that and we could figure out what's going on. So at this point, we've gotten to a system that looks like this. Now, we don't need to write this out to solve this problem, but being able to write this out on a regular basis is going to be really helpful later in the chapter, so I'm just going to go ahead and do it. All right, so if I want to maximize revenue, what I'm really trying to maximize is 535 times y, that's 25, 35 times y, plus 419 times x, right? Subject to all of those constraints that I just brought up, right? So those constraints were, I had 2x plus y less than or equal to 12. I had x plus 2y less than or equal to 12. I had x greater than or equal to 2, and I had y greater than or equal to 4, right? No big deal. So this is what's known as a linear system, this guy right here. This is really handy, and it helps us to keep things in line. I encourage you to, on a regular basis, go ahead and write out your linear programming system. It's going to be useful. All right. Now we could try all 4 of those points. And with just 4 points, it's really not hard to do. But there's another piece of information that we have here that's going to help us to establish the best way to go about this. So, and I don't think this is oriented properly. Yeah, let's go around and to the right. There we go. All right. So, we're going to talk about the corner point theorem. The corner point theorem tells us that the optimal solution will always be one of the corner points of the feasible region. So that means that even way up here when we were looking at this big area, we know that the maximized option is going to be either 0, 0, 0, 6, 4, 4, or 6, 0. So down here in our little region, we've got these 3 points, 2, 5, 2, 4, and 4, 4, that we can try. What that means is we can take each of those, 2, 4, 4, 4, and 2, 5, and we can try them out in this this maximization, right? So if we take this and we put them in, we can say, okay, so times 2, right? Times 4, times 4, times 4, and prove this to yourself, right? Like, it's really easy. Oh, I did those wrong because this was y, wasn't it? This is 4 and this is 2. Pardon me. Prove this to yourself. Don't take my word for it, right? Pause the video. See if you can get these calculations to come out the same way that I do. Anytime you're doing math from a video or a book or whatever, it's a good idea to go back and double check yourself and make sure that you know how those numbers came about, right? Don't just go trusting everything that you see. So if I do these calculations, I end up with this revenue. For 2 batches of cake cones, 4 batches of sugar cones, I end up with $27.46. For 4 batches each, I get $38.16. Oops. And for 2 batches of cake, 5 batches of sugar, I get $35.13. So So clearly the winner, right, is this guy here. Right, there's our clear winner. And so we know we can optimize by making 4 batches of each. Because this problem comes with constraints, though, it's not enough to simply state the maximum revenue and the corner point that revealed it. Instead, we need to attend to all parts of the problem context, which means what's the maximum revenue? What production provided it, right? And did we use up all the available hours to do so? Now, that seems silly. I know it seems a little pedantic to say, no, you have to go and figure out what happened in the baking and mixing departments. But when you think about it, like if you're running a company, you need to know that, right? That affects your labor costs. It affects benefits that you're paying out. It affects how you hire, right? All those kinds of things. It also affects, like, how do you care for your employees? Are they getting the hours that they need to make a living? All that kind of thing. Sometimes the most efficient way is not the most caring way. But anyway, that's just me. It's a tree hugger in me. What are you going to do? All right. So what I find out is this. If I was to take this information right here, this maximized revenue thing, let's plant it down here and let's re-examine it. I'm going to add a column to the right, or yeah, to the right over here. And I'm going to say, so what happened, right? What was the result? For 4. We decided that was the optimal solution. So we end up with a revenue of $38.16. We already know that. We also know that if we take 2 times 4 plus 4, we're going to end up with exactly 12, right? 8 plus 4 is 12. So 12 hours are going to be used in both the baking and mixing departments. So the full solution here is that the company should make 4 batches each of cake and sugar cones. Doing so, they will use up, they will make $3,816 in revenue and use all 12 hours available in both the mixing and baking departments. Okay, and that is a complete answer, which is going to feel a little annoying right now, but I promise you in the long run it's going to be really useful to you. As you do your homework for this chapter, you're going to want to be that complete with all of this. You're going to want to make sure that you're always looking for the most complete answer. Even if they don't ask you for it, go ahead and find what all the parameters are doing. So if we go all the way back up here to our organizational scheme, we should be accounting for the number of batches of cake cones, the number of batches of sugar cones, and what's happening in the mixing and baking departments. All right, so I'm going to leave it there. You have the tools that you need right now to look at sections 5.1 and 5.2 in your homework. And when I see you on next Tuesday, I will start by asking you to give me your questions, and we'll talk about those, and then we'll continue on into 5.3 and 5.4. So have a good weekend. Thank you for your patience, and I hope we all feel better, in particular me right now. Okay, bye.